Algebra 2, Chapter 16, Section 1, Matrices. So we're going to introduce a new concept today called a matrix. Okay, and a matrix you could think of as a two-dimensional array or table of numbers. A matrix has m rows and n columns. Okay, in general, and we call that an m by n matrix. So we read this times as by. Okay, so in this particular matrix, m is 2 and n is 3. There are 2 rows going left and right and 3 columns. A matrix variable is usually written with a bold capital letter, and the array is often placed in parentheses like this to show us that it's a matrix. In other books, actually, matrices are often used with braces as well. In some cases, you'll see matrices without any marking, just numbers in an array or grid. So this is a 2 by 3 matrix because it has 2 rows and 3 columns. A plain number, like we've been using up to this point, is simply called a scalar to distinguish it from a matrix. It's called a scalar because when we multiply a plain number by a matrix, we'll multiply every entry in the matrix by that number, which will scale the matrix. That's why it's called a scalar. To refer to a specific entry in the matrix, we'll use subscript notation in row, then column order. So and we'll use a lowercase letter matching the letter of the matrix to represent that entry. So W23 is row 2, column 3. So you go down to row 2 over to column 3, and that entry is 60. So if we were to say, what is W12? That's the first row, second column, 120. And W21 is the second row, first column, 275. So let's do some practicing with this. 2 different plans are proposed for renovating a residential property. Plan A involves less carpentry but more plumbing and electrical work. Plan B involves more carpentry but less plumbing and electrical work. To model the plans, they are placed in a matrix where each plan is a row. So here's Plan A in the first row and Plan B in the second row. And the columns represent the carpentry, the electrical, and plumbing hours for each plan. Evaluate each expression and say what they tell you about the 2 plans. A, W12, first row, second column, is 120. That is the hours of electrical work. I think it was actually carpentry. We may have this maybe backwards. No, it's electrical is the second row. Sorry, the second column. Hours of electrical work for Plan A. For Plan A. B, W21 would be the second row, first column, 275. 275 hours of carpentry work for Plan B. C, W13 would be the first row, third column, 80, minus W23, which would be second row, third column, 60. Which is 20. And what that means is we've subtracted Plan A's plumbing work from Plan B. So this is the number more hours of plumbing for Plan A. 20 hours more plumbing in Plan A. Matrices of the same size can be added. So we can add W to some other matrix S and get T if they have the same size. So if W is a 2 by 3 matrix, S has to also be 2 by 3, and the result will be 2 by 3. Okay, so we cannot add a 2 by 3 matrix and a 3 by 3 matrix. Cannot do that. To add 2 matrices, we add each of their elements. So we just take the first row's element from the first column and add it to the first row's element, first column of the other matrix. Matrices can be multiplied by a scalar, which means to multiply every element by that scalar. And matrix addition and scalar multiplication have the same commutativity, associativity, and distributivity as real numbers. So find given W, 2 times W. Okay, well we just have to double each number. 400, 2 times 200 is 400, 240, 160, double 275 would be, so it'd be 50 shy of 600, 550. 80 is 160 and 60 is 120. That would represent if we had to do double the work, or make these plans happen twice, maybe. 1.1 times W, we are taking basically 10% more, multiplying by 1.1, so that'd be 220, 132, 88, 88 here, and 66. 275 would be adding 27.5. Let's just do that with the calculator. 275 times 1.1, 302.50. 302.5. To budget for delays, we can allow for overruns in work using matrix S for each plan. So we'll give a different amount of extra hours of carpentry and plumbing and electrical and plumbing, depending on the plan and how much extra work we think that might involve for each plan. So here are the two matrices. Find W plus S, which is the same as S plus W. Like I said, addition, we can reorder, regroup, or distribute over scalar multiplication. So we just need to add the elements to get W plus S. 8 plus 200 is 208. 120 and 14 is 134. 11 and 80 is 91. 275 and 16 is 291. 12 and 80 is 92. And 60 and 7 is 67. So that's not too hard.